Thank you all for joining us this afternoon. We're just going to wait a few more minutes to start and give people a chance to log in. We'll get going here pretty shortly. Thank you. Good afternoon, everyone, and welcome to Genscape's 2015 CAISO Summer Outlook. My name is Ross Fessenden, and I'll be opening things up and then handing it over to my colleague, Chris Jilka. So just a quick rundown on what we'll be covering in today's presentation. We're going to open with demand factors, including a review of spring 2015, and then move into a look at summer temperatures and our precipitation forecast. After that, we'll move into supply, and I'll continue to talk on solar, including generation growth and impacts, as well as a brief bit about Genscape's solar model. I'll wrap up on drought and El Nino update, and then pass it off to Chris, who will take it the rest of the way and talk water supply update, as well as pricing and CAISO congestion. So beginning with demand factors, we're going to start by taking a look at the year to date. And looking at this slide, you'll notice that it's segmented into the January to March timeframe in the left column, April in the middle, and May on the far right. And what we're looking at in the top row are temperature anomalies, and in the bottom, precipitation anomalies. And really the take home here is that the first 3 months of the year, from January through March, were widespread above normal temperatures really throughout WEC, with California experiencing some record warm. And Across that same time frame, we saw abnormally dry conditions, especially concentrated, as has been the case in California and parts of Nevada. And really the only exception in the first 3 months to the below normal precipitation were southern areas of the Four Corners region, as well as northern areas of WEC. Moving into May, we saw those April, we saw those warm temperatures moderate a bit, still remaining above normal, but not to the degree that we saw in the first 3 months. And looking at precipitation for April, we did see a bit of moderation in the departure from normal in the dry direction, and we also saw a bit more scattered above normal precipitation conditions. Lastly, moving into May, we saw further moderation in those warm temperatures, with really a more widespread region experiencing normal to below normal conditions for the month of May, especially in southeastern California and other areas of the Four Corners region. And looking at precipitation, we saw very widespread above normal precipitation concentrated really in the Four Corners region, as well as the eastern portions of the Rockies. Now taking a more focused look on the March-April timeframe, and being mindful that climatology data doesn't publish for May until next week, so we're focusing strictly on March-April. Looking at the plot at the left, you'll see a lot of warm colors and some very deep reds along the coastline with number 121. And this is looking at the temperature rankings in a 121-year data set for the March-April timeframe. And the 121s on the coast of California in both central and southern denote that this was, in fact, the warmest March-April timeframe on record. And looking at the table in the top showing temperature departures, you'll notice that March was 10 degrees warmer in coastal Southern California on average than normal, so much so that it was warmer in March than it was in April, which normally is not the case. Normally April is a few degrees warmer than March. Looking at the precipitation trends across the same time frame, you'll notice again California was prevalently dry and well below normal, and these below normal conditions really persisted throughout the majority of WEC, with the exception of the Four Corners region being closer to normal. Now taking a look at demand recap for the spring. The top table shows 2015 spring peak demand numbers, with CAISO-wide peak falling at just shy of 34 gigs, April 30th. And looking at this in context with the previous 5 years, you'll notice that it was at the CAISO-wide level was 7.5 gigs lower than last year's peak of 41,486 megawatts. A few take-homes here. We do see, looking at this table, that there is a high variability in the magnitude of peak demand throughout the spring, ranging from just under 30 gigs in 2010 all the way up to 41.5 in 2014 at the CAISO level. And looking down at the bottom table, you'll notice that not only is it the magnitude, but the time that shows a bit of variability, ranging anywhere from the last day of May in 2012, seeing the peak, to as early as March 8th. This year's peak was relatively early, as we normally see a May peak for CAISO, and it did fall, as I said earlier, on April 30th. Now moving into the summer time frame, we'll first take a look back at the last few summers. We did notice that last summer's peak was actually the second lowest observed peak CAISO-wide since 2010, and PG&E load was the lowest of the last 5 summers at the peak level. The timing of that summer peak, looking at the middle plot, you'll notice in the June, July, August time frame, does traditionally fall after June, but you'll notice that there are several bold dates in that plot, and each bold date denotes a time where the peak demand for for the year actually occurred in September. So while this presentation is focusing on June, July, August, it is important to be mindful that the peak load can occur in the month of September. Moving down to the last chart, you'll notice historical summer cumulative demand. And interestingly enough, we saw at both the CAISO level and PG&E level a decrease in cumulative demand last year versus 2013. And this was a bit interesting considering that in PG&E, specifically, we saw record temperatures in the June, July, August timeframe. Again, referencing the plots to the right, you'll notice a similar temperature ranking plot to the one that I showed on one of the previous slides. And anything denoted with a 120 indicates warmest on record to that point. And so last year in Northern California as well as central coastal locations, they did experience the warmest on record. So looking further, comparing that to 2013, there was sustained warmth as well, but not to the degree that we saw in 2014. One reason we could be seeing a decrease in the cumulative demand from 2013 to 2014, despite record temperatures, is an increasing presence of behind-the-meter solar, especially in northern sections of California, that chips away at midday load. And as a result of that cheap midday pricing, the possibility that more pumped hydro units are doing their pumping during the daytime period as opposed to the overnight hours, as used to be the case. So one theory as to why we are seeing that deterioration in load despite warmer temperatures. Now taking a look at this plot, it is more of a visual representation of the slide that we just looked at. And the top line shows peak occurrence of demand at the CAISO level dating back over the last 5 years. The middle line shows the average from 2010 to 2014 across the summer months, and the bottom line shows the minimum. And as you can see, the biggest jump in demand tends to occur in late June, heading into early July. And this also is important to show that really the maximum is pretty volatile and can occur at any time following late June. Moving into the forecast portion of demand factors, we'll start talking about our summer forecast for 2015. It's important to understand the analog years that go into making our forecast, and some of the factors that we were mindful of in looking for analog years were similar El Nino conditions, as well as positive Pacific decadal oscillation that's decreasing in strength as opposed to increasing. And what we came up with were, for similar years, 1941, 77, 80, 87, and 2005. And you'll notice in the top portion of the graph that it's a composite of these analogs to give you a sense of temperature anomalies in the upper leftmost chart and precipitation anomalies in the chart immediately to the right. It's important to be mindful, though, that although we are looking for a cooler outlook in portions of California and the greater West, these analogs didn't have similar long-standing drought conditions as to what we're experiencing now with record and historical drought in place. So this is the composite Genscape 2015 summer forecast for the months of June, July, and August. And as you can see, there is generally above normal conditions in the coastal areas of the Pacific Northwest and the majority of the state of Washington across that time frame. Normal conditions throughout the remainder, with the exception being slightly below normal temperatures, pretty much focused on the Four Corners region and trailing into Southern California. From a precipitation standpoint, we do see the best chance for below normal precipitation occurring in the extreme northwestern sections of the Pacific Northwest, as well as above normal conditions in a swath moving from Idaho east through Wyoming, Utah, and Colorado. Taking a more month-by-month look at this, you'll notice that June, we do see interior sections of WEC experiencing slightly above to some areas experiencing much above normal temperature conditions. From a precipitation standpoint, you'll notice widespread near normal precipitation, with the best chance for below normal precipitation occurring, again, coastal areas of the Pacific Northwest. As we head into July, you'll notice a shift in temperature expectations with coastal and some interior portions of the Pacific Northwest standing the best chance at both above normal as well as much above normal temperature conditions. And the Four Corners region, once again, the focus of slightly below normal temperatures heading into extreme Southern California, including San Diego. From a precipitation standpoint, we do start to see departure from normal in the positive direction, with some areas stretching from just east of Idaho through Wyoming, Utah, and Colorado, seeing much above normal precipitation. Looking at the month of August, you can see temperature reflected on the left, precipitation on the right. We do start to see much more widespread below normal temperatures take hold, and the better part of the southern half of California is expected to experience slightly below normal conditions, and that stretches all the way into northeastern sections of WEC and even much below normal conditions encompassing the majority of the state of Montana. On the right, precipitation really overall stands the best chance at seeing near normal conditions throughout, with the exception of a small portion of Wyoming having a chance at seeing slightly above normal precipitation. We'll now move into the supply section of our presentation. And to start, we're looking at a net qualifying capacity comparison. This is a report published by the CAISO comparing 2014 summer on-peak net qualifying capacity by fuel type to 2015. And in this plot, you'll notice that the big takeaways are solar generation increases pretty substantially, 51% increase in solar for 2014 versus 2015 as far as net qualifying capacity. And for wind generation, we also see a pretty sizable increase. While it's only on the order of 0.5%, while it is on the order of about 0.5%, the year-over-year increase is on the order of about 24%. So on the subject of solar generation, this is a look at hourly real-time California solar generation dating back to June of 2012. And it's really remarkable, the increase in solar generation year over year, with the most recent solar maximum occurring as recently as this week, May 31st. It reached 6,051 megawatts of generation in California. And it's even more impressive that the rate of build-out and increase in solar generation has completely masked any seasonal variability that one would expect to see, with peaks generally occurring in the June-July timeframe. There's no real discernible peak in the majority of this 4-year look back. And really, with this unprecedented and rapidly increasing growth, really highlights the importance of having an accurate solar forecast to capturing everything going on in the California market. Now, covering some of the impacts that solar generation and the rapid increase has had, we'll begin by looking at and noting that there's a marked difference in relationship between midday and early morning prices when comparing 2014 to 2015. The table at the bottom shows a snapshot of January 1st through 8th of this year compared to January 1st through 8th of last year. And the big takeaway from this is that the difference between the the mean cost of energy for hours ending 1 through 6 in real time, differenced from the average of MCEs across hours ending 10 through 15 in real time, went from seeing the morning off-peak period 20 cents cheaper than the 10 through 15 time frame in 2014 to now, as a result of an increase in solar generation, this most recent year, 2015, midday pricing was $5.83 cheaper than the morning off-peak period. And the rightmost column in that table shows you the increased solar generation across those same hours, and you'll notice that it increased by nearly 1.5 gigs year over year. Now, translating this into market impacts, you look over on the right-hand side, and you'll notice two plots showing Genscape monitored plants and their output. The top plot is a solar unit, SEGs 8 and 9, and the bottom plot is Helms pump storage. And you'll notice the areas in the boxes are showing you the impact that the solar generation during the midday time frame is having on the frequency with which Helms pump storage is pumping during midday hours, as opposed to previous instances where it was much more common to see it pump at a greater degree during cheaper off-peak hours. So now we'll talk a little bit about Genscape's solar model and the plants that we monitor. We now monitor 8 solar plants, 7 of which do inject their power directly into CAISO. And the aggregate of those units is 1,835 megawatts of solar capacity, so between 25 and 33% of total California capacity. The solar model that Genscape has developed and is currently in a beta state predicts utility-scale solar generation for both photovoltaic and concentrated solar for CAISO solar units. This model was built using radiance, weather, and sun angle data. This forecast also is an hourly one that extends out 5 days, and this 5 days is important to note, seeing as how the California ISO only provides currently a day-ahead forecast that is for an undisclosed subset of solar plants in the state of California. And lastly, you'll notice that the inputs that drive this model on a daily basis are zenith and azimuth angle, temperature, dew point, humidity, wind speed and wind direction, cloud cover, and precipitation. Now we'll move into a drought update. And what you see here is the most recent plot of current drought status on the left-hand side. And on the right-hand side, you'll notice a look back 1 year on May 27th, 2014, and the drought status there. In general, we've seen drought improvement throughout the Four Corners region, especially eastern areas of WEC and the Four Corners. That said, we have seen a drought worsening really throughout the majority of California and the Columbia Snake Basin. The only areas in California that really saw a marked improvement were extreme southeastern areas and extreme northwestern areas of California. Only 25% of what the U.S. Drought Monitor defines as the West is currently in a drought-free state. And really, the exception to this is the Eastern Rockies, where you see a lot of areas in white denoting that they are drought-free. As far as the highest drought category goes, D4, also known as exceptional drought, there's been a near doubling year over year, and all of that has occurred within both California and Nevada. Now taking a look at the Climate Prediction Center's Drought Outlook and how it compares to ours. Their expectations are very in line with what Genscape is expecting, as our generally normal to below normal precip forecast for both California and western areas of WEC does favor both the persistence and development of drought in this area. Meanwhile, the normal to slightly above normal precipitation that we anticipate near the eastern Four Corners does favor both improvement and, in some cases, removal of drought conditions. Moving on to an ENSO status update. El Nino conditions are present, and you'll notice in the plots on the right have increased drastically across all El Nino ENSO regions since the March timeframe. Currently, the anomaly for ENSO region 3.4 stands at 1.29, the highest that we've seen during this current El Nino event. And they've identified that there is a 90% chance that El Nino conditions do persist through the summer, and an 80% chance that we see those conditions last through the end of 2015. And with that, I'd like to hand it off to my colleague, Chris, who will discuss the rest of our presentation with you.
Thank you, Ross. I wanted to remind the folks out there that if you do want to ask a question, you can type it into the box there. So starting off with the water supply update, here's a snapshot of the WEC water supply in terms of average precipitation and snow water content. And you can tell the theme of the year is that the water year, which begins October 1st, year to date is 75 to 100% of normal, according to the colored boxes in that left-hand graphic there, which corresponds to 75 to 100% of normal. But a sharp contrast to that is the slide to the right of the snowpack, or the snow water content. And the takeaway from this slide is that you can see all the zeros and single-digit numbers that happen to lie in the prime water supply area, specifically Washington, the Idaho Panhandle, and even eastern Montana. So what does this mean in terms of, California hydro production? So this is a slide of California hydro supply going back. It's both historic and forecasted supply going back 5 years. So you can see the last normal year was 2011, and then since we've been in I think it's almost a 4-year drought now, the corresponding supply curve gets lower and lower as we get to this year. In the black is the actual California ISO hydro year to date, and the orange line emanating from the end of the black line is our Genscape hydro forecast for the California ISO, which comes from our long-term WEC model. And Ross mentioned El Nino a little bit. Those effects are usually felt starting in the California rainy season, which is October through March. And if you see the plot of our forecast, it starts to track last year. It's a little bit below, starting in September. So we'll monitor El Nino pretty closely and make changes to our curve based on our observations. So why is Northwest hydro supply really important? Historically, the Pacific Northwest imports on the two main interties, Packy and Knob, have historically constituted 10 to 14% of the total California ISO supply. The Northwest River Forecast's current water supply forecast for the Dalles, which is the benchmark forecast for really the mid-sea system, for the April-September timeframe is about 71% of normal. So in context, this is the 5th lowest water supply year on record in 55 years. In the most recent history, 2001 was the worst, and if you remember, California had a crisis in that year. And then speaking to the California Summer Assessment, which is published on the CAISO's website a couple of weeks ago, when they published their summer assessment, that forecast was 80% of normal. So it's dropped 10 percentage points since their summer assessment came out. And the graphic below kind of depicts what the water year looks like, with the blue bars being the observed runoff at the Dalles Dam and the green diamonds being the 30-year average. And you can see where the trend starts to change as we move from March to April, where the early rains and warmer weather start to erode the snowpack. And that snowpack is primarily responsible for the magnitude of imports on the Packy and knob lines. So right now we're looking at a graph and going from left to right. The black line is actual imports for this year. The blue line is a 4-year average of Pacific Northwest imports, and these are Packy and knob combined or aggregated. And then the orange line is the Genscape forecast of those specific imports. And you can see what jumps out is the black line, how it's much greater than the average in the early winter, as those warm temps and rain in the Pacific Northwest cause more hydro than usual and more power being shipped south into California. And then as winter starts to turn into spring, you see once again the effect of that minimal snowpack as the expected spring freshet is minimized, and now you have your actual imports dipping pretty far below the 4-year average. And our forecast is basically for them to stay about where they are at these current levels to the end of August and then start dipping in July and then possibly catch up in the end of September or October to the 4-year average. So switching gears a little bit, we're going to talk about pricing and congestion trends. So looking at that June through August time frame again, a good way to look at overall congestion price is through the absolute value of constraint shadow prices, and that would be the marginal value of relieving a particular constraint. So we're looking at two different graphs here. The graph to the left is June through August day-ahead congestion shadow price. So this is the sum of the absolute value of all the prices in that time period. And the graph to the right is the same exact data, except now we're looking at the real-time market. And a note from this slide is that in 2014, we started using the data from the FMM market, which is the 15-minute market, started in May of 2014, and that was in compliance of FERC Order 764, which basically forced the ISO to start intra-hour scheduling to facilitate the integration of these renewable resources that Ross was referencing earlier. And the takeaway, obviously, is that we're seeing a lot more congestion in both markets 2014 than we did the prior year, 2013. So now we're going to look at day-ahead market on-peak transmission congestion trends. So we'll look at this in terms of the 3 major supply hubs and the 3 major demand hubs. So ZP, SP, NP, PG&E, SCE, and San Diego for the DLAPs, or where load gets their power. You can see how I highlighted the orange boxes there, and the black bars show you 2014. So you see the big year-over-year change from 2013 to 2014. And PG&E DLAP saw the largest increase in 2014, and that's related to constraints primarily in the Fresno area. And then San Diego also saw a very big percentage increase over the prior year, and that's mostly related to Bar Villa Park 220 kV line constraints. So to further drill down a little bit more into this specific time period for 2014, we rank the constraints here from 1 to 10. And you can notice right here that 6 of the 10 constraints are in this greater Fresno area. And it's of note that about 2,800 megawatts out of 3,800 megawatts of supply come from hydro resources in that area. And once again, I don't have to remind you that we're in the prolonged drought, with this year being the worst than the prior couple. Peaking summer load congestion occurs primarily to protect the 230 kV backbone that delivers imports into this specific Fresno area. And the next slide will highlight that a little bit more. So what you're looking at here is a simplification or a one-line diagram of the Fresno area, and this is from the California ISO website. LCR is the local capacity requirement, And that prior slide ranked the constraints. So 3 of those strongest constraints are adjusted to protect for thermal overload and contingency loss of this Gates-Gregg 230 line, which if you look towards the lower part of the oval, Gates and Gregg are highlighted with little black ovals, and then there's an arrow and a dashed line which shows you that line. In general, we expect this trend to continue into this summer. So switching markets now, we're going to look at the same data, but in the lens of the real-time FMM market. You see a very similar pattern to the day-ahead market, but the changes in congestion are not as pronounced year over year. For 2014, the price impact was larger than in the DAM market, but the constraints bound less consistently. So an example of that would be the Hentap Gates constraint. It was binding about 3% of real-time hours versus 21% of all the DAM hours, but the price effect on the PGAE DLAP was $5.40 versus $2, so double the magnitude. And then another takeaway would be the red bars are 2012, and that was a big year in California when San Onofre retired, and a lot of associated constraints popped up after that. So similar to the day-ahead market, these are the top FMM transmission constraints in the June-August period of 2014. You can see that there's a San Diego constraint in the middle. Once again, it's the impact of low hydro. The Fresno area, once again, is a big theme, and as we said, in the day-ahead market, we expect that to continue. TM bank flow, which is the 8th largest constraint of that time period, is primarily due to unscheduled flow from the northwest, and with much lower hydro expectations this year, we do not expect that constraint to be much of a factor at all. So in summation, real-time FMM has a similar congestion pattern to the day-ahead market. Once again, the Fresno area. And what was a little bit different is that the SX-TAP mission constraint and TL230S overload had a larger effect on the San Diego FMM price than it did in the day-ahead market. And moving forward to this summer, TL230S overload, I believe, has been renamed I-Valley El Centro. So you won't see that same constraint this summer. SX-TAP mission, we think that's associated with high levels of load in the San Diego area and plant outages. And then last year we saw some of the highest real-time load values in San Diego in 5 years. And given our summer outlook, we expect much lower values this coming year. Now we're going to move over to trends in the intertie transmission constraints for both the day-ahead and the real-time market. Once again, the 2 charts with real-time on the left and day-ahead on the right. And you can see what stands out are the large values of 2011 and 2012, which were very big hydro years for the Northwest. In contrast to this year, 11 and 12 were the 4th and the 6th wettest years on record out of 55 years. And this year, in contrast, is ranked way down at the bottom, 52 out of 55. So keeping with the theme, lower Pacific Northwest hydro flow expected means less congestion on the interties this summer. Now we're going to switch gears again. This is actually some work we've been doing internally. We've spent a year beefing up our internal nodal congestion analytics, and the results can be seen in our congestion section of our CAISO Power IQ product. So this is an example of the nodal congestion page, and this is a screenshot from a couple days ago. This is an example of our Balday report, and we actually forecast what particular constraints we expect to bind for this particular day. And then we highlight the source and sinks max megawatt, which is the CAISO's biddable limit for that particular node when applicable. And if you look at the top value, it's pretty hard to read, but this particular constraint is the path 15 constraint, and the driver is a D rate of 3,300 megawatts and moderate solar generation in SP. And in the risk column, in this case, we risk stronger negative congestion in the south in the real-time market with strong wind and solar expected in the middle of the day for that day. Then another example of the reports that we put out every day. This would be our outage report, which is located right to the right of our nodal congestion tab. And some of the drivers on the prior report you can find in this. If it happens to be a particular transmission outage that's driving the congestion, it will be here. We get this data from the CAISO, and their raw data can be hundreds of rows long, and we apply a filter that strips out the descriptions such as hot wash, test, RTU, and that only gives you the outages that affect transmission flow, making it much easier to digest on a daily basis. And you have some of the sources that we list. Well, that's about it, and we appreciate your time this afternoon. We will allow a few minutes for questions now. Like I said, there's a text box on your display. And then a lot of people have asked me prior, the slides will be available later through an email link that will be sent to you. So thanks again.
We do have a question in the forum asking, could you speak to how the WEC system will perform if the sustained heat in the Pacific Northwest continues through July? Specifically, will there be any bullish price patterns that develop at NP and or SP if the Mid-C system becomes strained? And the answer to that is sustained heat in the Pacific Northwest will absolutely lead to bullish price patterns in all three locations, NP, SP, and Mid-C. One of the reasons that we haven't seen more drastic response price-wise in California is that some of the above seasonal temperatures are leading to lower demand presently, and we currently have enough idle gas to come on to meet that demand, whereas as we move into the summer months with higher demand, the system will definitely become a bit more strained, and you'll see more of a price response as a result of that. There's another question asking for a clarification on slide 16, asking whether that includes residential solar, and that does not. The ISO reports exactly how much utility scale solar generation reaches the grid.
All right, we have a question coming in. How much total generation capacity has the CAISO added since the summer of 2014? I believe the summer assessment I mentioned previously says about 2.3 gigawatts of generation, and it's pretty much all solar and a little bit of wind and just a smattering of gas, but it's pretty much all solar. We have another question. It says, do you think the EIM, which is the Energy Imbalance Market, will have a big impact in the CAISO markets? So far we've not seen a big impact of PacifiCorp joining the CAISO balancing markets last fall. That's in terms of the day-ahead market. I think the interchange in general is pretty minimal between PAC and the CAISO in terms of the total CAISO load, but there's a lot coming down the road. Nevada is joining the EIM this fall. Puget and APS are slated to join in 2016, and I think the Oregon PUC is ordering Portland General to look at it. And the big one is APS, which is considering joining the CAISO as a full participant. And since the Southwest sees the greatest amount of interchange with the CAISO, when that does happen, if they become a full participant, that could really change the whole CAISO since we've been looking at it.
All right, that's all the time we have this afternoon. Thank you all again for joining. Any questions that went unanswered, we will respond to. And if there are any further questions, please feel free to reach out to either myself or Chris Jilka. Our contact information is on the slide. Thank you again, and have a good day.